Hello everyone, here we are going to present our project to you. First of all, we introduce you to our team consultant, Professor Dr. Haidar Livateri. Then our members are Abdulrahman, Abdullah and Anas. So saying Bismillah, let's dive into the real work. There is a critical problem in the field of chemical spraying industries. So let's see what's that problem. Working in such hazardous fields requires the workers to obey strict health and safety regulations, and unfortunately, in reality, the workers don't obey them usually. And we also have the fluctuating level of product quality when it comes to manual spraying processes like painting or other chemicals spraying. And not to forget that workers usually bend, couch, and stay in other positions that often strain the body while working with manual spraying guns. So, as it can be deduced easily, these problems cost the related companies a lot of financial expenses and harm the health of their workers. After looking for the available solutions in the market, we did a brainstorm session and came up with the table that compares the solutions with respect to the most important criteria in the field. We can easily notice that the Cartesian robot has the best total score out of other solutions, in which it's a pioneer in controllability, maintenance, material usage efficiency, cost, and safety. I think that you have already expected our selected solution regarding the previously mentioned comparison table. Yeah, it's the Cartesian Autonomous Chemical Spraying Robot. This robot can be implemented easily for various applications, and it can work in 5 degrees of freedom workspace by taking a 3D model of an industrial part. Then it starts spraying a chemical solution over the part autonomously with respect to the extracted dimensions and parameters via the specifically written algorithm, of course. The selected solution has its needs and requirements, so here we can see each need with its corresponding requirement. For example, in order to obtain a healthy environment, we have to have an autonomously operated robot. And to identify the shape of the object for the robot to spray, we will use an algorithm to extract the STL file data of the object and generate movement instructions accordingly. And to conserve the sprayed material, we need to focus on transfer efficiency term. This term refers to how much paint covered the part compared to how much paint got wasted. So this will lead us to choose the right paint sprayer. In order to obtain homogeneously sprayed layers, we have to design a precise control method for the industrial robot to be more consistent than manual operators, or let me say than manual operations, and in which the robots become more unlikely to make mistakes. Here we present to you the sequence of how our robot works. As you can see at the beginning of the flow chart, the part gets positioned at the exact spot, then we insert the 3D model of the part to our system. And then the written algorithm extracts and analyzes the surface's coordinates. Then our code generates the needed movement instructions, and these instructions go to the control algorithm, which in turn sends control signals to both the motors and the spraying nozzle. Then the spraying process starts while the axial and rotational movements are getting executed simultaneously.
Now, here we listed the main motivations of our project for you to see. So our robot will help reduce the contact between the workers and such previously mentioned hazardous environments. Also, it will improve the general quality of the products, and it will increase the quantity and speed of the work. It will also help us get more practical experiences in terms of such engineering projects. And finally, as we can see, the market size of painting robots has increased up to 11% in the last 5 to 6 years. Now let's come to the way that we will measure our success in the project and to tell you about the limitation that we may face. Our criteria is planning and studying every step of the project in detail, planning weekly meetings between team members, completely finishing the prototype of the project around July 2023, and not exceeding the specified budget for the project. And here are some of the problems that may slow down our progress. The lack of experience in our team about some topics, that we still have to learn throughout the design of the project. And of course, not to forget about the time difficulties and study workload due to other classes. And because of that, the time duration for such preparations will be a little bit short for us. Now here we aim to be more specific and explicit, so we are presenting to you the general technical requirements for our project. First, we have metallic sigma structure profiles for the mechanical structure, a track rail mechanism for the axes to slide, stepper motors that will generate the movements, motor drivers for controlling the steppers, border contactors as encoders, a power supply to power the whole system, Raspberry Pi as the main brain of the system, a graphical user interface and communication system to establish the needed interactions, a suitable spray nozzle for the spraying process, a chemical solution storage tank, and an air pump. Followingly, in order to sum up all the previously mentioned information, this slide shows the quantitative and qualitative targets of the project explicitly. So, the quantitative targets are reducing the number of workers to at most 2 workers per workshop to monitor and maintain the robot, spraying chemical solutions 8 hours a day without a break and producing the exact same pattern every time, saving 20 to 30% paint or other coatings. And our qualitative targets are increasing the quality and accuracy of spraying processes, creating a homogeneous sprayed chemical solution layer with minimal errors, and making the robot as easy as possible to be constructed in any workshop field.
In the implementation sequence, firstly we will start with building the mechanical structure of the project using SolidWorks and Siemens NX. And for the electrical circuits design, we will use Proteus and Altium Designer. And finally, we will implement the simulation and the algorithms using MATLAB and Python. It is easy to confuse what is included in the tasks of a project and what is not. So to be very clear, here are the in-scope tasks and the out-of-scope tasks of our project. The in-scope tasks are extracting dimensions from the 3D model, generating movement instructions, and spraying the chemical solution on the outer surfaces of the part. And some of the out-of-scope tasks are spraying multiple parts at the same time, spraying the internal invisible surfaces of the part, and spraying large-sized parts. Now, for us to be disciplined in achieving the needed tasks, we constructed this milestone schedule that has the time distribution of the main topics that will be carried out. It is worthy of mentioning that this schedule may be adjusted throughout the project according to any new emerging situations. And to be more consistent and precise, we distributed the tasks on our team members. But this does not mean that we are working separately. We will be cooperating together to achieve every single task. To wrap it all up, here are the final expected deliverables of our project in this semester. A complete 3D model that shows the 3D structure of the robot, a sufficient algorithm that reads inserted 3D models and processes them, a decent control theory to control the Cartesian robot, a simulation of the behavior of the robot, and a final technical report for all of the work. Our project stakeholders are the, in the first place, we have built workers and sequentially all of the chemicals related companies. Then we have our consultant, mechatronics department, and in the end we have health and safety organizations. So that was all we have, and thank you for listening.